Okay, today we are going to start day 2 of graphing rational functions. You might want to take a moment and get out a sheet of paper or go to your packet under the warm-up page and copy down this little set of notes I have. It's a little bit of review from day 1 graphing. Remember, when we're graphing rationals, we're looking for vertical and horizontal asymptotes. And there's 4 different situations we can come across for the horizontal asymptote. The first one being where the degree is higher in the bottom. Okay, we get our horizontal asymptote will always be y equals 0. Okay, doesn't matter what the numerator is. We're looking at the degree, comparing the degree of the numerator and the denominator. If the degree is higher in the bottom, y equals 0 will be your horizontal asymptote. Second situation is, what if they have the same degree? Okay, if they have the same degree, then we're going to compare the coefficients. For example, if I had 4x minus 1 on top and 2x plus 3 on the bottom, both of these functions are degree 1. They're linear. So when I say compare the coefficients, I am going to compare the 4 and 2. They are the coefficients for the x terms. And your horizontal asymptote would be y equals 4 over 2, or just y equals 2. The third situation is sometimes a rational. It's written in what we would call standard form. You might recall the h and the k. Okay, this form, when we see it written, when we see a rational function written in this form, the horizontal asymptote is always whatever the k value is. That's what moves our graph up and down. The fourth situation, hence is where we are heading today for day 2 of graphing. It's a little bit harder to get the horizontal asymptote. In fact, there is not a horizontal asymptote. That is what happens when the degree is higher on the top. Okay, in that particular situation, there is no horizontal asymptote. We get the slant asymptote. And we will be discussing that today. So here are the 4 situations we could have. You get your horizontal asymptote a little different. For situation number 1, if the degree is higher in the bottom, it will always be y equals 0. For situation number 2, when the degree is the same, we are going to be comparing the coefficients. Situation number 3, the rational function is written in standard form, so you have your x minus h plus k. The horizontal asymptote will ever be what your k value is. Fourth situation that we did not touch in day 1 graphing is what happens when the degree is higher on top. Well, there is no horizontal asymptote. It's a slant asymptote. So there's actually a diagonal. Okay. Keep in mind for every one of these situations, the vertical asymptote comes from the bottom, where the bottom equals 0. Okay, that's your denominator equals 0. So we find the vertical asymptote the same every time. We're just concerned where the bottom will be 0. All right, we are now on page 9 of your notes, and we're going to look at problem number 1. So we will be referencing, please make sure you have a calculator with you because we will be using the calculator also. So first thing I do when I look at these problems is I ask myself, is the degree bigger on the bottom or the top? Well, if you look at this problem, this is a constant. The degree on the bottom is a second degree polynomial. So we're bigger on the bottom. So my horizontal asymptote is y equals 0. I also take the time, and you do need to do this when anytime a graph has an asymptote, you do need to take the time to highlight that and dot that in. It helps you graph. All right. To find the vertical asymptote, we always look at the denominator, and we set the denominator equal to 0. And we start to solve, and we should start seeing something here. Don't forget your plus or minus because it's a squared, but look what happens. Plus or minus is square root of -2. Okay, we have a negative inside a square root, which gives me an imaginary. Okay, so for this particular graph, there are no vertical asymptotes because we cannot graph an imaginary vertical asymptote. So once you've figured out your vertical and horizontal asymptotes and you're given a calculator, I always suggest go to the calculator and let's type this graph in and see what we get. So you do alpha y equals, allows me to get a numerator and denominator, and then I type in your graph. So we have 3 over x squared plus 2. And then we do zoom 6. So let's look at this graph. As you can tell, it looks a little different because it does not have a vertical asymptote. So when we look at this graph, you can clearly see the horizontal asymptote is y equals 0. Even though it looks like it lies on that line, we have to understand that when we're graphing rational functions, the end behaviors of the graphs, they love to go towards the asymptote. So I always tell my students then, let's get some good points. And since we're graphing rational functions, when you go to your table, you're not always going to get a lot of pretty points here, okay, because we're graphing fractions. But you should be able to get a few. So when I look through these, I think we should be able to graph -1, 1. I'm looking right here. 0, 3/2, and 1 and 1. So I go back to my graph, and I'm going to plot -1, 1, 0, 3/2. So of course I'm estimating that. Then 1, 1 was a point. If you go back to your table, you'll also see that -2, 1/2, and 2, 1/2 was 1. But these points here, if you notice, they're getting very close to that asymptote. And we're getting very, very, very close. So it's very hard for you to be able to plot accurate points. But you do need to understand that the end behavior of the graph is going towards those asymptotes. So let's finish some of our questions here. Let's look at the domain of this function. All right, here as you can tell, you read your domain left to right. We have no break, so it is all reals. Look at our vertical asymptote. We did not have a vertical asymptote, and our domain is continuous. Range is a little different. We do have a horizontal asymptote. So we are hugging close to those values of 0, but we can't be 0. But look, my top y value is right here, and that is at 3/2. That's why I put a hard bracket there, because it includes that value. Because we have an asymptote at y equals 0, we have no x-intercept. And the y-intercept here, remember, once again, you can go to your calculator for that y-intercept. It's right there at 0, 3/2. So our y-intercept here is 0, 3/2. So it's a different looking graph than what we've normally had, because as you can tell, we've had no vertical asymptotes. Our horizontal asymptote was y equals 0 because the degree is bigger on the bottom. So let's look at problem number 2. I'm giving you time right now just to make sure you have things copied down. Okay, problem number 2 looks very similar to problem number 1. Let's start with our horizontal asymptote. Please reference back to the first page. When you're looking at these, you need, for the horizontal asymptote, ask yourself, is our degree bigger in the bottom? Do we have the same degree? are we written in standard form? Or is the degree bigger on top? So when we look at problem number 2, my degree is bigger in the bottom. So my horizontal asymptote is y equals 0. Let's look for our vertical asymptotes. We always go back to the denominator for that. So I'm going to set that equal to 0. And once again, I'm hoping you're remembering your plus or minus because that's a squared. And look at what we got in there. We have a negative 4 inside the square root. So once again, I'm hoping you clue into that is going to give us an imaginary. Okay, we cannot have imaginary asymptotes. So there are no vertical asymptotes. So I'm going to take my time right now and dot in my horizontal asymptote. At this point, we got to go to our calculator, or you can start plugging x values in, but go to your calculator and type this in and see what points we can get. So I go back to my y equals. I'm going to clear out what I have in there. Remember, to get a fraction, it's alpha y equals numerator and denominator. So 12 over x squared plus 4. I'm going to look at the graph to get an idea of what we have here. So once again, when it's starting to graph, you can clearly see that we have a horizontal asymptote at y equals 0. There are no vertical asymptotes because there's no break in my graph. So let's go to the table and see what points we can get. Oh, so I'm looking here. I probably can graph 0, 3. That's a good one. Negative 2, 3/2. And probably 2 and 3/2. Those are some points I could probably plot and be pretty accurate with. So I go back to my graph. I'm going to plot 0, 3. Okay. Once again, I'm pulling that right off from my table. Then I'm going to plot negative 2, 3/2. So I go over to negative 2. 3/2 is about 1.5. I'm going to go over to 2 and go up to 3/2. So here's what my graph is. Remember, what's that end behavior wanting to do? Wants to go towards those asymptotes, almost where it looks like it's lying right on top of them. So when I look at the domain here, I'm seeing that this graph is moving left to right and there's no break. So my domain is all reals. Okay, range, we read from the bottom to the top. So I see that my y values are getting pretty close to 0, but they can't equal 0, hence that's why I've softened that bracket up. And then the highest y value I get is 3. And it can actually equal 3, which means I put a hard bracket. Because my horizontal asymptote is y equals 0, look at that, there's no x-intercept. My y-intercept, once again, we can pull right from the table. You've plotted your point. So there's a couple ways. And you're at 0, 3. So the first two situations here, we've had the degree bigger on the bottom. That was something we dealt with day 1. The new thing we were looking at is, well, what happens when there are no vertical asymptotes? So situation, problem number 1 and 2 both had a degree bigger in the bottom, but we had no vertical asymptotes. When you are ready, let's flip your page over. Let's look at page 10. I apologize, page 10. Okay, we have 2 more situations that we're going to be looking at. All right, let's look at number 3. I start with the horizontal asymptote because that's something we have done and dealt with day 1. I'm looking at the numerator and denominator, and the degree is the same on the top and bottom. And when by degree, guys, I'm looking at my variable and I'm looking at my exponent there. Both of these are a degree 2 polynomial. So when the degree is the same for the horizontal asymptote, I compare the coefficients, the numbers out front. So my horizontal asymptote here is just y equals 1. Okay, so I'm looking at these numbers out front. Even though there's not a number written there, we know that it is 1. Vertical asymptote, I'm looking at the bottom now. I'm going to set that bottom equal to 0. And then I'm going to solve. And look what happens here when I go to solve. Remember, I have to add the plus or minus. But this time around, it is a positive 4. So I have 2 vertical asymptotes. Okay, that's the first time we've come across that situation. So I have a plus and minus 2. That's 2 vertical asymptotes. I'm going to go ahead and sketch my asymptotes in. So I have 1 at -2. That's a vertical. I have 1 at 2. And then I have 1 at y equals 1. So you definitely need to sketch in your asymptotes. They help you graph. Because we're graphing a rational function, the points are not always pretty, which means there's some ugly fractions. But we know what the end behavior of a graph is trying to do is head towards those asymptotes. So at this point, we look at our graph. It's definitely split up into 3 parts. So let's type this into our calculator and see what we get, what the graph looks like. So once again, you go back to your y equals. We're going to type in the fraction. So it's alpha y equals numerator and denominator. So I have x squared minus 9 over x squared minus 4. So I'm going to go ahead and hit graph. So as you can tell, when it starts to graph, we have 3 parts to this graph. Okay, we have here on the left-hand side of -2, we have what's in between -2 and 2. Then we have what's on the right-hand side of 2. Okay, probably the hardest point to get is when you've got this quadratic in the middle here, that minimum point right there. So we have to be pretty careful when we plot that. So I have my students always, let's go and look at the table. Okay, notice on the table, -2 error, 2 error. They tell you your vertical asymptotes. So let's look at the left side of our graph. Let's get a point there. So that means I want to be on the other side of -2. Looks like -3, 0 might be the only pretty point we have. Let's go back to our graph and let's plot -3, 0. So notice, guys, that's one good point, but if you look at your graph, what's that end behavior doing there? Okay, it's really heading towards those asymptotes. So that's something you need to show in your graph. It's almost like it's lying on top of those asymptotes. Okay, that's just one part of that graph. And I pulled that point from my table, -3, 0. I'm going to go back to my calculator. I'm going to save my middle part for last. I'm going to come over here and do this part. So when I go to my table, I'm going to look on the other side of 2. I'm going to worry about what's happening between -2 and 2 later. Look, I get 3, 0. That's a nice point that we can graph. So on the other side, I'm at 3, 0. And we know that the end behavior there is going to get very, very, very close to that asymptote. So we have 2 parts of this graph. Now we need to figure out what's going on between -2 and 2. So I go back to my graph. So I'm worried about these points in between here. And I think I can plot 0 and 9/4. It's about 2.25. Should be able to do that. That's a good point to get because that's the y-intercept. Okay, and then what do we know this end behavior, this quadratic is going? It is really heading towards those asymptotes. It's like they're magnets. So that's a pretty good graph there. We have 3 parts to it. So let's talk domain. On domain, we read left, to right. So we've got two breaks in our domain. So we're going to go negative infinity to negative 2. Then we're going to pick back up at negative 2 to 2. That's this middle part. And then we're going to go from 2 to positive infinity. Now let's look at the range. Remember, we read range from the bottom to the top. Okay? So we're here, we're thinking negative infinity to 1. And then we're at 1 to infinity. When you look at the x-intercepts, okay, you can get these a couple of ways. One, you can go to your table. They're nice. Ours are clearly nice this time around. 3, 0, and if I keep arrowing up, you will see negative 3, 0. So they happen to be nice integer numbers, so I got them right from my table. Another way to get the x-intercepts we referenced in day 1 of graphing is the x-intercepts is where the numerator equals 0. You can always also get them from your calculator. The y-intercept, easy way to get that is from your table, because where its x is 0. So we have 0 and 9/4. So this one was different because although we dealt with the same degree on top and bottom, so our horizontal asymptote was 1, we had 2 vertical asymptotes. Give you time to make sure you can catch everything and write it down before we do the last problem. Okay, the last problem deals with, if we go back to the very beginning of our page, deals with this fourth situation where the degree is bigger on top. Okay, so a big thing you need to recognize is when the degree is bigger on the top, there is not going to be a horizontal asymptote. There's going to be a slant asymptote. That means it's got a slope. So it's a little bit harder to figure out. Let's go back to that number 4 there. So when you see a problem like this, okay, we should probably reference that there is no horizontal. It's going to have a slant. I'm going to show you in a second how to get that slant. The good thing is the vertical asymptote, we still get the same. Where does the denominator equal 0? So at x equals negative 2. So that part doesn't change. But how do we get this slant asymptote? It's a process that we've used. It's called synthetic division. What we really need to do is actually a long division problem. We need to take that denominator and divide it into our numerator. That's something called long division. But because that is a linear factor, we can do synthetic division. If you recall from synthetic division, x plus 2 is the factor. What would the 0 be? It would be negative 2. And then we're going to run synthetic. Remember, with synthetic, we just use the coefficients. So we'd have 1, negative 2, negative 3. So with synthetic, remember, x plus 2, I must use the 0 of that, and then I'm using the coefficients. And remember, I have to have an x squared, an x, and the constant. So I'm going to drop the 1, I'm going to do my multiplication, 1 times negative 2. I'm then going to add these and I get negative 4. I'm then going to multiply and I get 8. Remember, this last number was always our remainder. Okay? It doesn't have to be 0 here because we're not saying x plus 2 is a factor or a solution of x squared minus 2x minus 3. So we really can just disregard this. We don't need that last number. We need these two because we took this quadratic and we are down to a linear. So the equation of this would be x minus 4. This is your slant asymptote. So now we have to go back to our graph and graph it. So I'm going to go back to my graph. And remember, our slant asymptote was y equals x minus 4. Now, how do we graph something like that? Well, we start with the y-intercept. So we go down 1, 2, 3, 4. So I'm going to plot 0, negative 4. My slope is 1, guys. My line should be rising. So I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. I can go down 1 over 1. Are we good? And so there is my slant asymptote. Next thing I would say to do is let's go to our calculator and let's look at this thing. Okay, so you go to your calculator, go to your y equals, clear off what you have, alpha y equals numerator and denominator, and let's type this in. Okay, I bet when you go to graph this and you look at that graph, you're going to be clued in, something looks different. The graph actually looks like it's trying to head towards a slant asymptote. It's different than something you've seen before. And you're probably asking yourself, oh, there's only one part to this graph? Well, no, there's another part. So we probably need to hit zoom and maybe zoom out one time. And then you'll see that other part. When you look at the graph, you can probably tell that there was your slant asymptote right there. Okay, it's kind of hard looking at the graph to get what it is, what the slant asymptote would be. That's why we use synthetic. But looking at this graph, we can see that we do have a vertical asymptote still, but then we have this no longer a horizontal but a slant. So we can go to our table. You can tell negative 2 was your horizontal. I'm sorry, was your vertical. So let's get some points, but look at these points. So I'm going to look at this part of my graph right here. And the only really good point I'm probably going to get is negative 3, negative 12. So I'm going to go back to my graph, come over negative 3 and count down 12. Okay, so your graph's going to go something like this down there. It's going to be hard to get some other points there. You possibly could do negative 4, negative 21 halves. Some of the points are pretty ugly, but you need to realize that you are heading towards those asymptotes. So let's see what's going on in this part. So we go back to our calculator. I want to be on the other side of my asymptote. So it looks like there's some points I can graph there. I should be able to graph negative 1, 0. Okay, I should be able to graph 0, negative 3 halves. Because that's like negative 1.5, remember. And then I think 2, if we look at where it's 2, 2, negative 3/4. So we can go over 2, negative 3/4. So we're kind of getting an idea that our graph's going there and it's really heading towards that asymptote. So sometimes if you forget that the degree is bigger on top, because that's a degree 2 polynomial. This is a degree 1. The degree's bigger on top. If you forget how to get your horizontal asymptote, you could type it into your calculator, and you could clearly see by looking at the graph, like, oh, this graph is definitely slanting. That's why it has a slant asymptote. So let's look at the domain. The domain of this graph, you read left to right. So we're still negative infinity to negative 2, negative 2 to infinity. The range of this graph would be tough. Depending on your teacher, sometimes you read it from the bottom to the top still. Some people reference that point right there. Some actually have you calculate the max and the min of that point. You know, you have to use your calculator for that. If we use the intersection point there, it would be negative infinity to 1, 2, 3, 4, 5, 6, negative 6. I think the more accurate way would be to go back to your graph and calculate what is that min? What is that max? So remember how we do that. Second calc. Let's do the min first. So we hit 3. Okay, remember we just use our left and right arrows. Get on the left side of that min. Get on the right side of that min. And then we don't want to guess. So it's about what? My y value is at negative 1.5. Which is negative 3/2. Okay, slightly rounded there. Let's find our max. So I'm going to do second calc again. This time I want a max. Okay, now remember it's tempting to hit down, but we have to hit over. Okay, and then I want to be on the left side of that max. And then on the right side of that max. And I don't want to guess. So I'm about at negative 18.4. Or negative 10.4, sorry. My old eyes. So we're at about negative 10.4 there. So that way if you were to do your range using your max and your min, okay, and I'm going to step over my y-intercept here, you would be negative infinity to about negative 10.4. Then you would pick back up at negative 1.5 to positive infinity. And I'm actually, should correct myself and make these hard brackets. I apologize because it actually can be those values. So for this particular problem, I would say the range can be a little challenging. And depending on your teacher, what they would allow to be acceptable. But remember, you can find your max and mins on the calculator. X-intercept, remember my trick is that it's always where the numerator equals 0. So you certainly could solve that. We know how to solve a quadratic. Or, just so happens we did get a little lucky here. If you go to your graph, go to your table, we are lucky because look at what we have. Negative 1, 0, 3, 0. Yay, they were nice integer numbers. How would I have gotten that here? I would have factored. So this would have been x minus 3 and an x plus 1. Notice if I factored them and I solved them, I have my solutions. But by all means, you can look at the calculator. Y-intercept, go to your calculator. Where is x? 0. So I might have clicked real quick through that. So this is definitely one of the more challenging problems because the degree is bigger on top, which means we run across where we have to be able to find that asymptote because it's on a diagonal, slant. So just once again to review that process of synthetic division, this was our denominator, x plus 2. Okay, we had to use the 0 of that, and then we had to run synthetic using our numbers out front. We don't care about that last term there You all were always hoping in Unit 5 for it to be a 0. It meant it was a factor and a 0, but that's not the purpose of synthetic at this point for us. Okay, we're using synthetic because we have a linear factor here, and we want to get what that slant asymptote is. So we're using synthetic in a different way. Not in a different way, but we're using it for a different purpose. So once we sketch in the slant and the vertical asymptote, you do need to go to your calculator and try to see what's going on. Make sure to be careful that, for this particular graph, we had to zoom out a little bit because this piece wasn't even showing. The domain, we still get the same because it's that vertical asymptote. Okay, now the range, that was the tricky part. Okay, and like I said, that depends on your teacher. Some want you to find that max and that min. Okay, the x-intercept, remember that's where your numerator equals 0. So you can do some good old factoring, good old, Unit 4 stuff to find those x-intercepts, or you could go to your calculator, and the y-intercept is nice, go right to your table. So I'll give you a moment here to make sure. All right, I do want to reference back to the very first page one more time. Okay. There are 4 situations when you're graphing a rational function. And we know something's rational because it's fraction. We have a fraction in it. You have a top and a bottom. So, and your degree is higher on the bottom. Your horizontal asymptote will always be y equals 0. Degree's the same, you have to compare the coefficients. Okay, if it looks like it's in standard form, your horizontal asymptote is y equals k. If the degree is bigger on top, okay, there is no horizontal asymptote. It will be a slant asymptote. Now, it does not matter what situation, 1, 2, 3, or 4 that we're in, the vertical asymptote always comes from the denominator. Always where the denominator equals 0. So today, we did show you a special case where we did not have vertical asymptotes. That's like number 1. Okay. And number 2, did not have a vertical asymptote because when we set the bottom equal to 0, we got x squared equal to a negative number. Problem number 3 was special because we had 2 vertical asymptotes. So we went from no asymptotes to 2. So we just wanted to show you that you can have a graph that has 3 parts to it. And then the 4th situation we showed today, probably the toughest, was what happens when the degree is bigger on top. It tilts your graph, so you have a slant asymptote. And remember, to get that slant asymptote, we had to do synthetic division.